Now that we started to be able to identify some of the key information from our equations, things like identifying what is our axis of symmetry or where our vertex point is, now we're going to start to use that to identify some key characteristics of the graphs, and then we go ahead and actually graph the data and see what it looks like. So we're going to fill in these couple things real quick into our notes, and then we're going to practice just a little bit. So the graph of a quadratic function, as we talked about, is a U-shaped curve, and we call it a parabola. That's its mathematical name. Okay? The graph can be folded so that the two sides match exactly, kind of that middle line that perfectly divides it in half. And this is called symmetry. The line that divides it in two equal parts is our axis of symmetry. And that's what we've been calculating or finding here over the last day or so. Okay? That axis of symmetry, or sometimes we'll abbreviate it as AOS, axis of symmetry. And then the last part we've been working on is the vertex of the parabola is the point where the parabola crosses that line or crosses that axis of symmetry. Kind of that is either the very top or the very bottom of the graph, kind of where it changes directions and head back in the other direction. So now we're going to be given some equations, and then we are going to go through some steps to calculate each of the different parts. So the first thing you're going to do for each of these is determine the pattern. So if your parabola opens up, that means your A was a positive number. If your parabola opens down, that means your A term, that first number out in front of the parentheses, is going to be a negative number, telling us that it's headed down. If it is narrower, A is greater than 1. Okay? So think of it as it's larger than 1 or larger than negative 1 in magnitude. If it is wider, then that means our A is less than 1. So think a decimal or a small fraction, okay? Something between -1 and +1. And that's going to make it be wider than the original. Then we're going to identify our vertex. Remember, that's just our H and our K from the equation. Our axis of symmetry is just X is equal to our H value. Then we're going to make a table starting with a vertex, plug in a couple of other points, get our data, and then plot those points. And what you're going to notice is, remember, it's exactly the same on both sides. So once we can plot points on one side of the graph, we know that there's a mirror image on the other side. All right, so let's see this in action. So first, we focus on that A value. Here, A is a -2. So a negative number means it opens down because A is a negative. And then because A is a 2, that means it's going to be narrower than y equals x squared, narrower than our parent function, because the absolute value of A is bigger than 1. So what it's doing is it's causing the numbers to rise quicker and quicker, so they don't have as much time to spread out in both directions. So I'm going to do my vertex first. My vertex is my H and my K, so 4, 5. And my axis of symmetry is just that H value, x equals 4. Since this is going to turn down, think of like an upward or downward facing U, my vertex is my maximum, the highest point. For domain, remember the domain's always the same, x such that x is all real numbers. My range depends on which direction it's heading. So in this case, y such that y is less than or equal to 5. 5 is going to be that high point, and I want everything below that 5. All right, so now we're going to do our table of values. For this, it is okay to use your graphing calculator. You can type in your equation and then go to the table function, and it'll give you those values. Or you can just plug in some numbers in a regular calculator, plug them in for x into our equation, and solve for y. So I always start with my vertex, 4, 5. So that's this point here. Then I'm just going to go up by a couple. So maybe 5, 6, 7. Depending on the graph, maybe you can get to that next one, but a lot of times it's grown so much that it falls off the edge of the graph and we can't fit it. So if I look at my table of values, for 5 and x, I get a y of 3. For an x of 6, I get a y of negative 3. And then for 7, I get a negative 13. So that's going to fall off of my graph there. So at 4, I'm at positive 3, but I'm going to be the same on the other side. Remember, it's a mirror image from that line of symmetry. At 6, I'm going to be down at negative 3, but that means at 2, I'm also going to be down at negative 3. And then at 7, it's going to be way down here, so I really can't fit it on the graph itself. So then I just connect my points to draw my graph. And then I always like to draw in my axis of symmetry. So this was my x is equal to 4. But that's all we want to do for each one of these is identify the key characteristics. What's it going to look like? What points is it going to start at? What's its domain and range? And then go ahead and graph the points. So for this one, start with our pattern. Well, we've got a 1. It's a positive number, so it's going to open upwards because A is positive. And then because A is equal to 1, so it's not bigger than 1, it's not smaller than 1, it's going to be the same size as our parent function y equals x squared. All right, that's my h, but remember it's always minus h. So in this case, my h is negative 3, and my k value is negative 4. So that means my axis of symmetry is x equals negative 3, because it's always that h value. Since it's opening upwards, I'm going to have a minimum value, the bottom of my graph. My domain is still x such that x is all real numbers, because I can put any x value I want into that equation. But my y's, I do have to be more limited, my range. Y such that y is greater than or equal to that k value of negative 4. All right, so let's graph it. So we're going to start with our vertex, negative 3, negative 4. So I'm at negative 3, negative 4. So then let's plug in some values. So maybe I do negative 2, negative 1, 0, and 1. Or you could go the other direction, negative 4, negative 5, negative 6, negative 7. But we kind of do a couple of them on that side, knowing that we're going to have the exact same thing on the other side. So with an x of negative 2, my y was negative 3. If I put in negative 1 for x, I get a 0 for y. If I plug in 0 for x, I get a positive 5 for y. And if I do a 1, I get a positive 12, because that's going to kind of fall off the edge of my graph. So let's go ahead and plot those. Negative 2 and negative 3, but I know I'm going to have a matching one on the other side. And then negative 1 and 0, so negative 5 and 0. Then 0 and positive 5, so negative 6 and positive 5. And then 1 and 12, so 7 and 12. So now I draw my graph and try to make as smooth of lines as I can heading in both directions. And then my last step is I always like to draw in that line of, or that axis of symmetry. So it's going to go right down through my graph, and that's x is equal to negative 3. All right, so let's do 2 more together. So here, my a value is a negative, so it's going to open downwards because I have a negative a. Because my a is greater than 1, it's going to be narrower than y equals x squared. Okay? So anytime that a is greater than 1, it means it's going to is going to grow faster, so it's not going to be able to spread quite as far. So my axis of symmetry is going to be x is equal to 4, because that's my h value. My vertex is at 4, 7. All right. Since it is opening downwards, I'm going to have a maximum. My domain is x such that x is all real numbers. So that one's consistent. For my range, y such that y is less than or equal to that k value of 7, because that's going to be my high point. So I'm going to have the point 4, 7. And then I'm going to add some more, so maybe 5, 6, 7, 8. Okay. I go ahead and I plug that into my calculator. If I plugged in a 5, I get a 5 for my y. If I plug in a 6, I get a -1. If I plug in a 7, I get a -11. So that's about all I'm going to be able to fit on here. So I'm at 4, 7, and I'm at 5, 5. So I'm also going to be at 3, 5. And I'm at 6, -1, and I'm at 2, -1, and 7, -11, and 1, -11. So I always know I'm going to have that matching partner on the other side. So I go ahead and graph it, and then I draw in that axis of symmetry, x equals 4. All right, so if you've got the idea, you're welcome to always try some of these on your own, okay? But otherwise, follow along with me, and I'm going to do one more. So here, I've got a -1, so it's going to open down because a is a negative. The absolute value of a is 1, so it's going to be the same size as y equals x squared. My axis of symmetry is going to be x equals 2. My vertex is 2, -2, because my k value is -2. Okay, since it's opening down, I'm going to have another maximum. My domain is always x such that x is all real numbers, and y such that y is less than or equal to -2, because it's all headed down from there. So I plug in 2, -2. So that's my first point. And then I plug in a couple more, so 3, 4, 5, 6. My calculator gives me -3 for 3, -6 for 4, and -11 for 5. So I plot those points 3, -3, so that's going to be 1, -3, and then 4, -6, and 0, -6, and 5, -11, and -1, -11. So I draw in my parabola, and then I always like to put in my axis of symmetry, x equals 2. All right, hopefully you got a pretty good handle on how to graph those and are ready to do some on your own.